Hi, welcome back to Unit 4. This is going to be the last topic here in Unit 4. This is topic 4.4. This is elastic and inelastic collisions. So in the previous video, the previous topic, we kind of established what conservation of momentum was. Here we're going to keep talking about it because in the last video, the focus was explosions. And in this video, the focus is going to be on collisions. So one thing to remember, regardless of what kind of collision it is, the momentum will always be conserved. And so what we're going to do is we got to look at how does that kinetic energy act? Is it going to be equal or is it not going to be equal? All right, so for elastic collisions, right, so this is the first type of collision. So for an elastic collision, the kinetic energy will be conserved. So the total initial kinetic energy will equal the total final kinetic energy. Now, what's going to happen is the kinetic energies will be different for each individual object, but the sum before and after will be equal to each other. Okay, it's not like it just simply transfers everything from one to the other. It's going to transfer based on the momentum. Okay. Now, the other type of collision is inelastic. And what happens is with inelastic collisions, the kinetic energy will decrease. And why does it decrease? Is because some of that energy is going to be transformed by non-conservative forces into other forms of energy. The common forms of energy that will show up, sound, heat, okay, just general deformations of the objects, will be reasons. And then when we talk about it, when a collision is perfectly inelastic, two objects will hit and collide and they will stick together and move off as a big mass with a common velocity at the end. Okay. And so there are different ways. One thing only for elastic collisions, right? So the initial velocity, some of the velocities will equal each other. So if I take the two velocities of object one, add them together, that'll equal the sum of the velocities of B, of the second object, right? So that should be a B, all right? Now, when it comes down to perfectly inelastic collisions, you'll have the sum of the momentum of the system. Sorry, I don't know what I was just writing there. So we'll have the before and that's going to equal the total mass times this common velocity. Okay. Now, sometimes an object will be, stationary before once it hits. Okay. And again, with elastic collisions, your final kinetic energy will be less than your initial kinetic energy. Okay. So that is for an inelastic collision. For elastic collisions, your energies will be equal. All right, so let's look at an example problem. So this is an inelastic collision, okay? So as shown in the figure above, it's actually below, a child of mass 20 kilograms is running at a speed of 4 meters per second, jumps onto a stationary sled of mass 5 kilograms on a frozen lake. The speed at which the child and the sled begin to slide across the ice is most nearly, okay? And so what we're going to do, we're going to, you can separate this into two different sides. Sometimes I like to keep it organized. And so before, you have M1 V1 before plus M2 V2 before. And that's going to equal the total mass because the child jumps onto the sled times this common velocity, which is what we're looking for. Okay. We know that this is going to be 0. That is the sled. So the before side is just M1 V1B. And then we have the total mass, right, times the final velocity. And so final velocity becomes the momentum before divided by the total mass, right? And so we're going to have 20 times 4, because the child is a 20 kilogram child is running at a speed of 4 meters per second. And then they're going to jump on a 5 kilogram sled. So you're going to have 80 over 25, which ends up being 3.2 meters per second. Okay. And sometimes they may ask you, like, what is the percent or how much energy is lost? So if you just simply did a K before calculation, and then you did a K after, right? You do 1/2 times 20 times 4 squared. And then here you do 1/2 times 25 times 3.2 squared. Okay, I actually did not do this calculation, but you get 16, it's 10. So this is 160. 12.5 times, let me pull out a calculator. So we should expect that, sorry. So 0.5 times 25 times 3.2 squared. So as expected, our kinetic energy did go down. So what happens during the collision, they lost 32 joules of energy, or, right, they may ask like a percent. So 128 divided by 160. So it's like it's at 80% of what it was originally. So that's 20%, right, so there's a 20% loss of energy. Okay. Again, that's just the type of questions that they may ask you. Okay, so now we finished Unit 4. Unit 5 and 6 are going to be rotation units. 5 is going to focus on basically kinematics and dynamics, and then Unit 6 is going to focus on the conservation law, so energy and momentum. And then we finish up the year with oscillations.